Hello, welcome to In 5 Minutes. Next question is to find the values of the current given in the question, that is IB, IC and IE. This is the current IE. You need to find the value of all the three currents and the region of operation of the given transistor. Now, when you apply KVL in the base loop, how to identify the KVL base loop? VB is given over here, so your base loop will be this one. So when you apply KVL to base emitter loop, what will be the equation for KVL to base emitter loop? It will be minus VBE, right? Positive negative, so minus IE into RE plus 5 equals to 0, right? So you need to find the value of IB. So minus VBE, instead of IE I can write it as 1 plus beta IB into RE plus 5 equals to 0. Now why 1 plus beta? I can write IE as IC plus IB. IC can be again written as beta IB. IB I am keeping as it is. So when you simplify, it will be 1 plus beta IB. So I can write IE as 1 plus beta IB, which has been written over here. So you can find the value of IB. What will be the value of IB from this? 43.06 microampere is the value of IB. This is how we have found the value of IB. Next we need to find the value of IC. How you will find the value of IC? It is beta times IB. What will be the value? 4.3 milliampere. Similarly, you can find the value of IE, which will come to 4.34 milliampere. Now to find VCE, what we do to find VCE? We apply KVL to collector emitter loop. So when you apply KVL to a collector emitter loop, you have V plus minus ICRC minus VCE minus IERE plus 5 equals to 0. So when you substitute all the values, you will get VCE as 3.51 volts. Now last part is to identify the region of operation. If you look at the diagram, this is your base, this is your collector, and this is your emitter. You can see the base is grounded. You are not supplying any voltage to the positive terminal of the diode. So how it is forward biased? You can see over here this negative supply of VBE is given minus 5 volts, and here you have 0 volts. You can say minus 5 is less than 0 volts. That means this is at higher potential with respect to this. That means nothing but we are forward biasing the diode. This is how this VBE is forward bias. Again, you can check VC is 3.7 volts. For the transistor to be operated in the forward active region, your VBE should be how much? 0.7 volts. That means it should be positive, and VCE value should be greater than 0.71, that is VBE on. So your VCE is greater than 0.7. That means the transistor is biased in the forward active mode. This is how more concepts are getting cleared with an example shown in the diagrams.